Unit 7, Lesson 13, Applying Modeling in Geometric Situations. Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8 inches and a diameter of 3 inches. To the nearest cubic inch, what will be the total volume of 100 candles? So diameter of 3 inches, I'm going to change to the radius of 1.5 inches, as you saw earlier. What would be the total volume of 100 candles? So in order to find the answer to this, we have to find the volume of one candle. And since we have a cone, that's 1/3 times pi r squared times h. So the product here is equal to 18.85 for one cone. Multiply that to 100 candles, that is, and we get 1885 cubic inches. Just in case you weren't aware, the outside height also serves as the inside height, so this is equivalent to 8 as well. And as you can see, we've got parallel lines that are equal lengths and height. So now Walter goes to a hobby store to buy the wax for his candles. The wax costs 10 cents per ounce. If the weight of the wax is 0.52 ounce per cubic inch, how much will it cost Walter to buy the wax for 100 candles? So we have 1885 for the volume of 100 candles, and that's cubic inches. We're going to multiply that to 0.52 ounces per cubic inches, and then we're going to multiply the cost of the wax, 0.10 cents, per ounce. So I can cancel out the cubic inches, cancel out the ounces, and get a product equal to $98.02. If Walter spent a total of $37.83 for the molds and charges $1.95 for each candle, what is Walter's profit after selling 100 candles? So we know he already has a cost of $98.02 for the wax. I'm going to add another $37.83 to that for the molds, because this is his cost that he needs to spend before he can start making any money. He has to pay himself back for the money he already put out. So that total cost is $135.85. Now if we take $1.95 and we multiply that to 100 candles, we get $195. And if we take the $195 and subtract his beginning incurred cost of $135.85, we get a difference of $59.15, and that's his profit. Example 2. Oh, this one is a multi-stepping doozy. The water tower in the picture is modeled by the two-dimensional figure beside it. The water tower is composed of a hemisphere, that's important, that's 1/2 of a sphere, a cylinder, and a cone. Let C be the center of the hemisphere and let D be the center of the base of the cone. Okay, so we're looking at this diagram here as a replica of the three-dimensional one here. So if AC is 8.5 feet, okay, I see that labeled, BF is 25 feet, and the measure of angle EFD is equal to 47 degrees, determine and state to the nearest cubic foot the volume of the water tower. So what we're going to have to do is piece this together. We're going to have to find the volume of the cone, we're going to have to find the volume of the cylinder, and we're also going to have to find the volume of a hemisphere, which is 1/2 of a sphere. Once we do all that, we'll add them all up and get the total volume of the water tower. H2O is an abbreviation, chemical abbreviation for water, and that's going to be the sum of all three of these. So let's just write the formulas. The volume formula for a cone is 1/3 pi r squared times h. A cylinder, it's pi r squared times h. And of a hemisphere, it's 4/3 times pi r cubed times 1/2, so it's 4/6 pi r cubed. Okay, so for the cone, I have 1/3 times pi times 8.5 square Okay, so we need to find the height. All radii are congruent. So this is 8.5, this is 8.5, this is 8.5, this is 8.5, and this is 8.5. And we need to find the height here. So we're going to have to use some trigonometry, which you already know. So from the angle 47 degrees, we have the opposite over the adjacent. So tangent of 47 is equal to x over 8.5. We cross multiply. And we get x approximately equal to 9.11. Let's try this again. 9.1151. That serves as the height of our cone. Go ahead and multiply all of these values together, and we get an approximation of 689.6513. Now the volume of the cylinder. Pi times the radius of 8.5 square times a height of 25 gives us an approximation of 57 674.5017, and the volume of the hemisphere, 4/6 pi times 8.5 cubed, gives us an approximation of 1286.2204. So the sum of all three of these volumes gives us a total of 7,650 cubic feet. So now the water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Justify your answer. So I'm going to use the volume that we just found for the entire water tower, which is a total of 7,650 cubic feet. And I'm going to multiply that to 62.4 pounds per cubic feet. So I can cross these off and get a total of 477,360 pounds. So now the next part is, can the water tower be filled to 85% of its volume? So if I take that and divide by 100%, I'm going to get 0.85. I'm going to multiply that to this number, in which case I get a result of 405,756 pounds. So the answer is no, because we have a value that's greater than 400,000, so it does exceed the limit.